So I welcome you all, everyone. Thanks for your this joining in this meeting. So this is the topic of that is a problem and solution of operating system. Just this course is designed basically for uh, in purpose of gate. Okay. So I have done in this class this already this topic, but in gate how this kind of problem will come. Then I have just talk to you in the class that in future we can discuss with this topic. So this we have an n enormous number of times, so we can discuss this particular thing. So first of all, in gate there are lots of subjects. So if you plan for gate, then this is my suggestion that I have checked that in 5 years marks distribution of theory of computer science means that automata is a minimum marks will come in this uh, gate is 3, maximum 8, and on an average each and every year from automata you can got 6 marks. In compiler design every year you got 4 to 5 marks. Okay, I will give you this PPT, so no problem for this that. Okay, so I have mentioned some reference books also that for theory of computer science, Bob Ullman is there, and so many books are there. So I will not waste my time here. I will provide you the PPT. Okay, digital logic is a subject. From that average marks, you can got 5.5 marks each and every year. In computer network, in average marks every year you got 8 marks. Operating system 8.5. So my suggestion is that if you target for gate operating system, you will got 8.5 marks each and every time. Okay, from memory and process synchronization, you got all sort of things. So in operating system, why I choose operating system in 5 years analysis? In average, you got 8.5 marks. Minimum will become 6 and maximum 12. Okay, so that's why, and it's a very pretty easy for target operating system in gate that so most of you people know about that the process thread and CPU scheduling. I also discussed in the class process management, CPU scheduling, inter-process communication, concurrency, and synchronization. Some sort of synchronization part is not covered in the class, but most of the things in process is already done. Okay, so now I just recapitulate this segment that basically problem based in CPU scheduling in process management. So those who attend my class, they can understood that we have discussed on preemptive and non-preemptive scheduling, FCFS scheduling, FCFS scheduling in a different arrival times, problem and preemptive priority CPU scheduling, problem for round robin scheduling, problem of round robin scheduling for different arrival time, problem on shortest job fast, that is called SJF, and SJF has two type. One is preemptive and non-preemptive. Shortest job fast scheduling with predicted burst time, longest remaining time first, LRTF, and multi-level queuing scheduling. Okay, so so these are 13 types of problem I have seen in the gate each and every year. Most of the time it will come in this particular problem. Okay, 13 types of problem is there in our syllabus. Most of the 7 to 8 we have already done. Few things we will also discuss in this meeting. Okay, so now you see that this diagram, I think everyone has know about this diagram. It's a process state diagram, which is new, ready, running, waiting, and there is another part is called suspended. The suspended is basically nothing but another process which is explicitly told is the process into go for the sleep. Then if it is awake, then it's called suspended. Okay, some sort of time it will basically stopped, so it's called a suspended. So if it is working inside of ready state, then it's called ready suspended. If it is working in a waiting suspended mode, it's called waiting suspended. Okay, so otherwise most of the things are same, that new, ready, running, terminate. And I have already discussed during the class that from running to ready, if it will come to running to ready, then definitely an interrupt is when it interrupt is occurred, then it will come from running to ready. And normal scheduler dispatcher is from ready to running. And similar for any IO interference is IO event is occurred and IO event completion, then the waiting segment is there. Okay. Now the next part is very important. This is CPU scheduling in a multi-programming. For that, how some sort of time, if you go through the diagram properly, then CPU burst time is there and some sort of time IO burst time is there. So in a scheduling concept, if you go for in a long-term scheduler concept, then CPU scheduling is there and IO scheduling is there. In this webinar, we will also discuss one problem in the last, where we can see that CPU scheduling plus IO scheduling is there. Okay. Most of the time we have done in the class that only CPU scheduling, but in this webinar we will go for last one problem, which is make with CPU scheduling and IO scheduling. Okay, so now I think that everyone know about this context switching and context switching to the user mode, jumping from the proper location to the another user program to restart the program. Okay, so this is a very common diagram of a CPU in CPU different scheduler component like ready queue. If it is go for the ready queue to CPU, then it's called a short-term scheduler. If it is go for the IO, then IO scheduler, then IO request, then the ready queue, then CPU. The total whole process is called the long-term scheduler. And this is basically different types of that CPU scheduler component is in a showing in a one picture. Okay, so if we go for the different short term, long term, and mid term, then if we go for some sort of that part, what is that? Is a long term scheduler. So if you have any question, then you can raise your hand. There is an option for raise your hand. Okay. And so now long-term scheduler, short-term scheduler, and mid-term scheduler. You know that long-term scheduler is a job scheduler, short-term is CPU scheduler, and mid-term is a process swiping and swap out. Basically done that swapping and swap out. Okay, and in terms of speed, short-term, long-term scheduler is lesser than short-term scheduler. Definitely, it will take some much more time. And the fastest one is the CPU scheduling, which is called short-term scheduler. And the speed of this midterm scheduler is in between to short-term and long-term. Okay. And obviously the degree of multi-programming. Degree of multi-program means what? That number of program is, if it is increased, then it's called a degree of multi-programming. It is in a long-term scheduler, it's controlled by that multi-program, degree of multi-programming. Okay. In short-term scheduler, it provides lesser control over degree of multi-programming. And in case of midterm scheduler, it reduces the degree of multi-programming for midterm scheduler. Definitely, in swapping and swap out process is there, then it's called a degree of multi-programming is working in a reduce that degree of multi-programming by midterm scheduler. Most of the thing is that that everyone that these are some sort of algorithm is there like FCFS, first come and first serve. So there is a process that uh, process arrival time and some sort of service time is there. Okay, so here it clearly depicts that in a Gantt chart, this diagram is called Gantt chart. That zero timing is there, zero arrival time is there, and service time is 8. So definitely first come it will take the first sub of P1, then similarly P2 and P3 and P4. From here, everyone I can say that everyone can calculate. If I say that the what is the average waiting time, most of the people can solve it. I think, right? Okay. So I will not go through that because you know that FCFS is a first come and first serve basis. So if you go through that, but it has some problem. We know that some convoy effect problem is there. So that's why we will go for short term scheduler. Like if I go for the short term, like here is a I have to find the shortest job first. Okay, so here this is depict that preemptive shortest job first. Preemptive shortest job first means what? It is nothing but a SRTF. In class I have go through this. Two type of short-term scheduler is there. One is preemptive, another is a non-preemptive, right? So preemptive is that what? Preemptive means that suppose I am working and some sort of time there is a provision if I quit without complete my job, it's called preemptive, right? So here the preemptive scheduler is there. So initially zero arrival time P1 is there, but it has service time is 8. But it is not a shortest job. Who is the shortest job? Here is a P2 is the shortest job, 4. So but practically zero time P1 is there, so automatically P1 covered. Then after that one when it is go through one, then automatically P2 is arrived. Then I will give a chance to the P2. So similarly, it will go for the once again P4 will get a chance because 5 is there, and once again in between 9 and 7 because P1 is already done 1. So 8 minus 1 that is 7. 7 and 9. Which one is the smallest? This P1 is the smallest, so it will get the chance. And similarly P3. Okay. So these are the shortest job first. Now the based on the priority. Priority means that you know that there is a scheduler is called priority scheduler. So short-term scheduler is also a priority scheduler. Short-term scheduler is also a priority scheduler, like because it will search for the shortest job. So similarly, that priority may be determined by the user or some default mechanism. The system may determine the priority based on memory requirement, time limits, or other resource usage. Another important part is called starvation. Starvation is, you know that the English meaning of starvation is that suppose any process not work each and every time, then it will go for the starvation section. So starvation occur if a low priority process never runs. The solution, how to solve this problem? This problem solved by getting aging to give the priority. Suppose if I victimize, then I will give some extra priority to that. The next time it will get the chance for the highest priority. Okay. So starvation, if it is a problem, then aging is a solution. Okay. Now similarly, another another algorithm is called round robin scheduling algorithm. Round robin scheduling algorithm. Everyone know that there is a time quantum. Too short time quantum is there. Too long. If it is too long, then there is some problem. So that's why too short. That means very short amount of time it will get. If it will give some to create a round robin, then everyone get a similar chance. Okay. So these are the facility of a round robin. So now I'm just giving an example of this round robin. Everyone you know that there is a time quantum is I think 4 is time quantum is there, and no priority based preemption means that a round robin there is no priority. It will work like a FCFS, but everyone is a given equal chance. P1 is get the equal chance 4 milliseconds, then P2, then P3, then P4, once again P1, P3, P4, and P3. So from here I can similarly I can calculate average waiting time. Okay. These all the what I have seen, what I have said that already I discussed in that class. Now this point is a new algorithm. Basically, this algorithm will come in a gate. Last 5 years, one or two times it will come. That longest remaining time first. It is nothing but a shortest. SRTF is there. SRTF means shortest remaining time. Which one is the shortest? Here I have to calculate that which one is take the longest. So this is very easy. Just you have to think about the longest remaining time. Like if I go through this P1, arrival time is 1 and bus time is 2. And see, everyone is here is a no zero arrival time. So if I have to go create this Gantt chart, then the first section I have to remaining blank because in this time CPU will not work. It's called CPU idle. Then you have to calculate this time also. Okay, so that means 0 to 1 CPU is idle because nobody is arrival on that time. Then P1 is arrived in a 1. Then P1 get a chance and brush time is 2. Okay, then I have to calculate the longest remaining time. Then P2, if I go in a P2, then longest remaining time means what? Which one is the longest? 8 is the longest. So, but 8 will come in 4 millisecond. Here I am in a 2 millisecond is there. Practically, this one is the highest priority. Okay. So similarly, I give a chance to P2 once again. Similarly for যেমন আমি P1 কে দিয়েছি. So P2 is get a chance 1 millisecond. Then similarly P3, then P4 will when P4 will come, then automatically see up to 7. The remaining time it will complete it. Is it clear? Okay, thank you. Shomo Ghosh has written that. Yes, sir. Okay, so please communicate to me. Otherwise, I cannot. It's not a two-way communication, so that's why problem. Okay, okay. Similarly, it is same like similarly for SRTF, and here is the longest remaining time first. Okay, then similarly you can calculate the average waiting time from here. Okay, so now, so these are the tricky question coming to get. This CPU idle time you have to calculate it because nobody here it is not started from 0 millisecond, it is started from 1. Now another question is that multi-level queuing system. These are the very easy. Multi-level queuing system is a diagram of this. If you go through this diagram, the highest priority and the lowest priority is there. System process, interactive editing process, batch process, student process. So these are the all the CPU scheduler, different type of scheduler is there. Suppose if I give the highest priority in a problem, I said that it's first one is a round robin, second one is the FCFS, third one is the SJF. So two, three, four type of different type of scheduling algorithm can work in a multi-level queuing system. If the if it is first one is there, then that means is the highest priority. The second one is there, then is the uh, second priority according to the highest priority. The lower one, the lowest priority is there. So if I go through a problem, then you can easily understood that. Okay, like multi-level problem. So now you see that here is a multi-level queuing algorithm. Process is there, arrival time is there, CPU burst time is there. The last one is that, which is very important, the queue number. If it is the highest priority, then queue number is 1. If it is then the second priority is there, then queue number is 2. Now here in this problem, they have said that priority of Q1 is greater than Q2. Definitely, I said that 1 means highest priority, 2 means the lowest priority. Then here 1 means round robin and time quantum is 2, and the Q2 is FCFS. Okay, so here I am putting in this problem into a Gantt chart that P1, here is the P1 is there. P1 is the Q according to the highest priority is that it's a uh, round robin. Okay, and the time quantum is 2. So here, though it is a 4 brush type, P1 will get a only 2 because according to the round robin time quantum is 2. Then similarly for the P2 is total CPU brush time is 3, but according to the time quantum it will get only 2. So 2 to 4. Okay. Now once again P1 will get an extra chance because 2 also remaining. 2 is there for remaining. So P1 will get a chance. Then 4 to 6. Now you see the P2. P2 is there, only 1 is remaining. 2 minus 3 minus 2, that means 1 is remaining. So 6 to 7 is there for the P2. And here you can see that the queue number is 2 and then 1 is there. So queue number is 2. What is the 2? Why we will not take this P4 previously? Why I am taking P3? Because the arrival time does matter, because P4 arrived in 10 milliseconds. So I have to give the chance for the P3 because practically P4 is not arrived. If it is arrived, then I will give the chance to the P4. Okay, here you can see that arrival time of P1, P2 and P3 is both are same, but only P4 is at 10 millisecond. Here you can see the Gantt chart that P3 will get a chance in a 7? You can ask that question, that sir, why P3 will get the chance? Because here in 7 millisecond P4 is not arrived. That's why P3 will get the chance. Okay, then it is complete, then it is 10, and similarly when the 10 is there, because the highest priority, it will not complete its job. P3, it will not complete its job, it will complete only 3. Then 10 is there, then automatically P4 will get the opportunity to run its program. So complete is 5 because it's the highest priority, and the rest of the part is P3 is done by 5 millisecond is left. Okay, so I think you can understood that the what is the flavor of a multi-level queuing system. Yes, am I right? Is it interesting? Okay, okay. So now I will go through a last problem. Uh, that problem is very interesting. Just go through the problem properly. Then this kind of problem will come in the gate, and it is very important. You know that I told you in the class that we will also go through CPU and IO problem similarly. So here is that problem. Problem is that this is the problem, that consider the three process all arriving at time 0 with a total execution time is 10, 20 and 30 units respectively. Each process spend first 20 times for the execution time doing IO. Listen carefully. First 20% of execution time done by IO, and the next 70% time done by computation. Basically, computation means using CPU, and the last 10% time done by CPU again. So the operating system use the shortest remaining computation time. That means SRTF. They are using that SRTF scheduling algorithm, and assume that all IO operation can overlap as make as possible. So they wants to know that what percentage of time does the CPU remain idle. The problem clearly mentioned that there is a three processes there, and they have 20, 10, 20 and 30 is there, and each process first 20% it will work in IO, then the next 70% done by CPU, and the third one, last one, is 10% done by IO. This is applicable for three process. Okay. So similarly, this table, process table, beside there is another table is called P0. If it is 10, then automatically 20% of 10 is 2, 70% is, that means 7, and IO for 1. And similarly for the P1 is 4, 14 and 2. And P2 is the 6, 21 and 3. Okay. So these are, I can clearly measure the CPU and IO work separately, right? Now how I have to do it, because according to the problem they said that we have to go for the shortest remaining time first, and I have to calculate that how much time CPU will remain idle. So here the green color is saying that IO scheduling. So first of all, IO work is started, so 0 to 2 millisecond IO. When IO is work, then after that P0 CPU will work. CPU, that means 7, so from 2 to 7, that means 9. Then after that P0 is working involved in IO, so that time P0 is work for 9, 1, only 9 to 10. Okay, then it's complete. Why I am made it green and red? Because there is a, you know that there is a color combination. You can easily understood that which portion is for the CPU, which portion is the IO. CPU means the red portion here, and IO means is a green. Okay, IO is working as a separate, CPU is working as a separate. Remember that picture. There is a ready queue is there. Okay, so automatically I will give this time, this P1, for the P1 it will give 4 millisecond for 4 millisecond for the IO. Here it is mentioned 10 to 14 for the IO. then automatically it will give 14 for the CPU. From 19 to 14, that means 23. And here this problem also mentions that they can overlap the time of CPU and IO time. Okay, so that's why here 10, 9 plus 14, that means 23 is there. And the last portion is for the P1 is 2, that means 14 to 16. Okay, 14 to 16. Then the last one is the P2. P2 is only CPU for the 16 plus 6, that means 22. And CPU time is 70%, that means 22 plus 21, that means 44. From 23 plus to 44, that means 21 millisecond time it will work for CPU idle time, CPU time. Okay, then the last one portion is P2, that means for the IO shielding, that is what is 3, that means 44 to 47. Okay, now here you can see that the all this red portion is similarly when the IO is work, then CPU also will work. So ideal time is how much? From here you can see that from 0 to 2, then that time CPU will not work, and the last portion for 44 to 47. So if I go through that explanation, that from 0 to 2 millisecond idle, the last part is 44 to 47 remain idle for the CPU. So total time spent, that means 47. So ideal time 2 plus 3, that means 5. So if I go for the percentage, then 5 divided by 47 into 100, that means 10.6. Okay, so if you have any question, you can ask question very quickly you can ask question. I think that if you go through this problem properly, then you can understand the flavor of these multiple, that CPU and IO problem. Okay, so if you have any question, you can ask me, sir, why there is no overlap in the first and second. In fact, you can see that this, just a minute. First, according to that, P0, first time it will only 20% time for the CPU, sorry, IO time. So that time P0 is only for the IO. There is no CPU involvement is there. So that's why 0 to 2 millisecond is not treated as a CPU time. Okay, it's a totally IO time. And my question is that, according to the question, they will ask that what time, what is the ideal time for the CPU? And you can see that here is the red portion is already similar portion of from 2 to 44. 2 to 44 is both is working for the CPU and IO. So these are the overlapping time. So I will not take this overlap time. I will take only the rest of part is the overlapping time. That means 2 and last 3. So 2 plus 3, that means 5. And the last time is 47. So 5 divided by 47 into 100. Am I making sense? Okay, so thank you for joining this meeting. So if you have any question, you can send me in my email ID. My mail ID is bhattacharya.sudipta@gmail.com. Okay, so once again, thank you all, and stay home and protect your community. Thank you.